Okay, everybody, we are going to do a sample homework problem just like you're going to do. You guys are doing 24, nope, 22. I'm going to do 23. 1 plus 2x under a radical. So f of x equals 1 plus 2x. All right, so what I asked you to do is first graph this to the best of your ability. I said you could use a calculator. I'm just going to wing it. All right, here's our graph. I'm just going to make a little table. Okay, x and f of x. So when I plug in 0, I get the square root of 1, which is 1. So plug in 0, I'm right there at 1. What am I going to have to plug in so this is 0? Well, if I plug in negative 1/2, I get negative 1, and that gives me 0. So negative 1/2 is right there. And you know that square roots kind of just go up and over to the right. So let me do another point. That's 1, and negative 1/2 gives me 0. Let me plug in 4. Why 4? Well, 2 times 4 is 8, plus 1 is 9. Square root of 9 gives us a nice round 3. 1, 2, 3, 4, and up 3. Okay, so there's my graph. Okay, we're going like that. So the second part that I want you to do for homework is to sketch your best guess of the derivative. All right, so I left the slopeometer in the classroom, but we'll just make believe. So likely this is quite steep. It's a steep positive slope that as I move this way, the slope is getting shallower and shallower and shallower, okay? So I'll go with blue. At this instant, it could potentially be infinity, so it might be high, but it's going to come lower and lower and lower. Is the slope ever going to be negative? No, but it's going to come down, maybe something like this, okay? Just the concept of the derivative as the tangent at any given point. Right here, that slope might be 1/3. Well, if that's 1, then maybe it would come down as low as that. So I'll maybe revise. And you might do a rough draft as well and come back, but it's going to come something like that. All right? So that's my derivative. This is f, so this is f prime of x. Now we're going to find it mathematically. This is a review problem. You should remember how to do this very fondly from your quiz. Okay? We're going to use, according to the book, the definition method. Okay? So we're going to say that it's the limit as x approaches a. And we're going to say f of x minus f of a all over x minus a. All right? So I'm going to leave this in general terms. I'm not going to plug in a specific point value. And we'll see what happens. Well, this becomes then the limit as x approaches a of my function, goes right there, with x in it, so it's radical 1 plus 2x, and then minus radical 1 plus 2a. When I plug in a for x, I get the same thing all over x minus a. All right? So I hope you're not tempted to want to do polynomial long division into that. You see those radicals and you think multiply by the conjugate. So I'm going to multiply by the number 1 in the form of the conjugate of this. So it's just going to be radical plus radical. This is my little shortcut to just save time writing. You can do it too. Because when I FOIL these conjugates, the same thing always happens. These first terms multiply and poof, the radical is gone, 1 plus 2x. Then I multiply these guys and poof, that radical is gone, 1 plus 2a. Keep that in parentheses because that's a grouping symbol for that radical. Well then, down below, don't forget about that. Don't forget the limit as x approaches a. Down below, it's going to be x minus a times, and I'm still going to go with my shortcut because I just don't need to spend the time writing it. Now what happens? Well, oh yeah, by the way, just remember, because of the conjugate, the rainbow bits always cancel. Just don't even think about it. I'm going to bring the minus sign in, like this, and guess what? That becomes a minus, and the parentheses go away. And I get 1's canceling, and I wind up with, I'm going to sneak it in over here because I'm running out of board space, x goes closer and closer to a, and I get 2x minus 2a all over x minus a times my 2 radicals. Keep that. Okay? Well, this is a great little problem. I think your other one's almost as easy. Nice thing is I can factor out a 2. This becomes 2x minus a. And then what happens? The x minus a's cancel, and I wind up with just 2 over this. I guess I do have room to write it, so limit as x goes to a of 2 over then I can write the radical part. It's 1 plus 2x plus radical 1 plus 2a. Well, as x gets closer and closer and closer to becoming a, I can just sub that in, and that equals a. So this is my limit. Well, what is this? This is 2 over 2 of those same radicals. I've got 2 apples, I can add them together. 1 plus 2a, and then look what happens, the 2's cancel. So the final answer for this derivative is 1 plus 2a. Okay, oops, radical. That is a square root. All right, so what I want you to do then is take that and type that into your calculator and see what that graph looks like. All right, as a gets closer and closer and closer to negative 1/2, right here, what's going to happen? Well, that's going to be closer and closer to 0, and sure enough, 1 over 0 explodes to infinity. Let's try plugging in our favorite point there. If we plug in 4, 4 for a is 8 plus 1 is 9, square rooted is 1/3. So when I plug in 4, look at that, that was almost exactly our guess. Okay? So you type that into your calculator and you'll see that your visual guesstimate of the derivative should be really close to the formula you get at the end.